Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 14th video in the Introductory Programming in Java full course and the 5th video of Lesson 3, Branching Structures in Java. In prior videos, we took a general look at conditional statements in Java. We looked at creating Boolean expressions with relational and logical operators and comparing strings using .equals and other methods, and then we looked at Boolean variables. In this video, we're going to look at different ways to test for more complicated conditions using and, or, and nested if statements. Let's get right into it. We're going to start with checking ranges using and or. If you want to know if a value falls within a range, you will use relational operators and the AND operator. A number line is very helpful for thinking about range checking. Here I have a number line with values from 300 to 900. Suppose I'm validating that the CO2 levels in a specific room are optimal for health based on a scientific assessment of the specific room and how it's used. Let's say we want to monitor that the value is between 400 and 800, including the endpoints. I've drawn filled circles over the endpoints and a line between them. Imagine that the CO2 reading is in a variable called CO2 reading. Then I will want to write a Boolean expression that will evaluate to true when the value in CO2 reading is on this line, so between 400 and 800 inclusive. I have a J shell open here. I'll define the variable double CO2 reading equals 600. Now we write the test with an AND operator like this. 400 is less than or equal to CO2 reading, and CO2 reading is less than or equal to 800. J shell responds with true because 400 is less than or equal to 600, and 600 is less than or equal to 800. Both conditions evaluate to true, so the whole AND expression is true. Now think about why you have to use AND here. To constrain the value within the limits, both of the conditions must be true. It must be both greater than the lower limit and less than the upper limit. If I use an or, the condition will always be true because any number is either greater than or equal to 400 or less than or equal to 800. Now, if I set CO2 reading to a value outside the range, such as 900, and execute the test again, it's now false. Think about why. 400 is less than or equal to 900, so that test is true. But 900 is not less than or equal to 800, so the second test is false, and true and false is false. Now, I want to note a couple of things. First, there are other ways to write each of the tests that are logically the same. For example, instead of the test on the left, 400 less than or equal to CO2 reading, I could have written CO2 reading greater than or equal to 400. That is the same test. Similarly, I could have written 800 greater than or equal to CO2 reading for the test on the right. I also could have switched the order of the tests, testing against 800 first and 400 second. I usually try to write the tests so that the values are in number line order, but you don't have to. The other thing I want to note is that we use less than or equal to and greater than or equal to when we are testing for an inclusive range, including the endpoints. If we didn't want to include one or the other or both of the endpoints, we would use less than and greater than. So if the test had been 400 less than CO2 reading and CO2 reading less than 800, then values of 400 or 800 for CO2 reading would result in the expression evaluating to false. Now, suppose we want to test for a value outside of the range. Instead of testing if the error is good, we want to test if the error is bad. Here's what that looks like on the number line. A value less than 400 or a value greater than 800. Here I'm showing the opposite of our original condition in which the 400 and 800 were included in the range of healthy air. So we want to know, is CO2 reading less than 400 or is CO2 reading greater than 800? It can be less than 400, or between 400 and 800, or greater than 800, right? It can't be any two of those things at once. It can't be both less than 400 and greater than 800. So when we're testing for a value outside of a range, we use OR. This test looks like CO2 reading less than 400, or CO2 reading greater than 800. J shell says true because remember, we set CO2 reading to 900. Note again, it can't be both less than 400 and greater than 800. I find that my students often find these conditions difficult to write. I think it's easy to think that a value less than 400 and a value greater than 800 should make this condition true, but not at the same time. The value can't be both less than 400 and greater than 800 at the same time. The variable CO2 reading will have a value in it, and that value might be less than 400, and it might be greater than 800, but it can't be both. Remember program state. You're testing the state in that variable, and you want this test to be true if it's 300, for example. You want the test to be true if it's 900, as it just was. So either below or above. And as with the AND condition, we use less than and greater than if we're not including the endpoints, but we use less than or equal to and greater than or equal to if we are. And these conditions can be written in different ways, such as 400 greater than CO2 reading, for example, and the order can be different, for example, testing the high range before the OR and the low range after the OR. As long as the logic is the same, it's the same expression. Now, in addition to checking for values within a range, of course, you can use the logical operators whenever you're testing a more complicated condition. Let's say you're looking in the closet at what clothes are clean, and you're checking the weather on your phone because you need to go to the market. If it's under 40 degrees and you have a clean sweater, you'll walk to the market. Otherwise, you'll do laundry. If it's 40 degrees or over and you have a clean t-shirt, you'll walk to the market. Otherwise, you'll do laundry. As with most programming problems, there are several ways you can write this sort of condition correctly in a program. Let's look at two. We'll write a program in Eclipse, and let's just quickly review how to do that. So in my Lesson 3 project, I'm going to right-click on the default package and choose New Class. In the name box, I'll write the name of my class, Laundry and Weather. Remember that class names begin with an uppercase letter, and then we use camel case when there are multiple words. I'm going to click the public static void main string args box, and then click Finish. Now we'll need some variables. Let's have a double for the temperature. I'll write a comment, declare variables, and then double temperature. And then let's have booleans for whether there is a sweater and a t-shirt. I'll write boolean has sweater and has t. If we're going to obtain those values from the user, we'll need a scanner. So scanner standard in, and let's import the scanner up at the top. And we'll just obtain these values from the user. So I'll write a comment, create the scanner, and obtain values to test from the user. Then I'll create the scanner and prompt for the values and read them in. For the booleans, I'm going to ask yes or no questions, convert the response to lowercase, and compare that to the string yes using .equals. I'm going to do this all on one line, so I don't need a separate string variable for that. So for example, has sweater equals standard in .next line, .to lowercase, .equals yes. That expression on the right will return true if the user types some version of yes at the prompt. If we read the temperature first, don't forget to consume a new line after reading in the temperature, but before reading our strings. Okay, now with that done, let's write our comparisons. Let's start with using logical operators. So if it's under 40 degrees and you have a sweater, you're going to walk to the market. We can write that expression with an AND operator, and we'll just print a message about what the person's doing. So if temperature is less than 40 and has sweater, system out print line, walk to the market. And now we're going to do this next one entirely with logic. So I'm going to write if temperature less than 40 and not has sweater, system out print line, do laundry. Okay, and we can write similar expressions for if the weather is warmer. If temperature greater than or equal to 40 and has tea, we'll print walk to the market. And then our final statement, if temperature greater than or equal to 40 and not has tea, we'll print do laundry. So that will work. Technically, there are 8 possible combinations of values for the inputs, assuming that the tests for under 40 and greater than or equal to 40 are written correctly. So to test this thoroughly, we'd want to put in at least 8 combinations of inputs. I'll just run it twice and leave the rest of the testing as an exercise for you. So I'll run it with 39 degrees and a sweater, and it won't matter what I put in for the t-shirt. And I'm told to walk to the market. And let's have 70 degrees and no clean clothes. And I'm told to do laundry. But this is inefficient because every time we run it, all 4 of the tests will run. The program will always check if the temperature is less than 40 and has sweater is true, and then it will proceed to checking if the temperature is less than 40 and has sweater is false, and then temperature greater than or equal to 40 and has tea is true, and then temperature greater than or equal to 40 and has tea is false. But we can see that if temperature less than 40 is true, we wouldn't want to then test for temperature greater than or equal to 40 being true, because it can't if temperature less than 40 is true. They're opposites or complements. We'll talk about complements more in another video. But hopefully you can see that the program really shouldn't have to do all of these tests. So let's look at a different way to solve this, a nested if statement. As I just noted, temperature less than 40 and temperature greater than or equal to 40 are opposites. So those could be handled by an if-else. If temperature less than 40, do something, else do something else. And we can assume temperature is greater than or equal to 40. Let's start writing the tests that way. I'll write a comment, do some comparisons with a nested if statement. And then I'll write what I just said. If temperature is less than 40, open close curly brace, else, open close curly brace. I want to note that style-wise, the recommendation from the Elements of Java style is to put the else on the line after the close curly brace, but I prefer to put it on the same line as the close curly brace from the if, and I apologize that it is different from the style guide I'm recommending. I think this looks better. I recommend you follow a style guide or do it this way, which is also a common way to write an if-else. Okay, let's think about the logic. What if temperature is less than 40? Then we'll want to take a look at the has sweater variable. So inside those curly braces, after temperature less than 40, we'll write another test, if has sweater, and then the walk to the market message. And then if the temperature is less than 40, so still inside the outer if, but not has sweater, we can use an else inside. So we'll print the do laundry message. Now in the else, now we know the temperature is greater than or equal to 40. So if has tea, we'll print the walk to market message, and else we'll print the do laundry message. Now, this is called a nested if statement because you have an if statement inside the conditional code of another if statement. And if you test this with the 8 different combinations of true and false for the 3 conditions, you'll find that this works the same as the statements above that use logic, but it is more efficient because each time through we're checking 2 conditions. First, the temperature, and that narrows us down to either checking sweater or tea. Okay, so as usual, I have included some auto-graded exercises in the description of this video so you can practice writing the ranges we wrote in JShell. And so you can practice writing the program with both the logical operators and nested if. If you get stuck, come back and watch the video. And as always, this program will be available in my GitHub repository. You might try variations on these programs and your own examples for practice. The exercises in the back of a textbook chapter on logic and writing conditional statements is a good place to look for practice problems. When you're feeling confident with the concepts in this video, you're ready to move on. As always, have fun and keep coding.